Okay, slang asymptote, guys. We have slang asymptote if the degree, remember we have two polynomials, no? P in the top, Q in the bottom. If the degree of P is greater than +1, +1, or is equal, let me put equal, equal is, bueno, the is verb is equivalent to say equal sign, degree of Q +1, this is degree, sorry, this is degree, is the only condition that we have, yes, we have a slang asymptote. I suppose you remember the horizontal is when you have the same degree, or the special case is when the degree of Q is bigger than the degree of P, but in this case, completely different. If the degree of P is bigger than 1, but no, only 1, not 2, not 3, not 4. One example to understand this. Look, one example to understand this. Example number 1 for today is, suppose f of x is equal x squared plus 1 divided by x minus 1. Well, degree of P is 2. Degree of Q is 1. It's exactly the condition that you need to have slang asymptote. Okay, we have a slang asymptote. Okay, entonces how you find the slang asymptote? Well, the slang asymptote is, do you remember the other asymptote that we are discussing, que is vertical asymptote, something like that, boom, 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 or horizontal, que is like that, boom, 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 boom. In this case, it's slang, it's like that, it's oblique line. And the equation for any line, oblique line, is mx plus b. I suppose you remember this formula. To get that, we are doing the division of this polynomial. Okay, you divide using long division, or you divide using synthetic division in this case, because remember synthetic division is shortcut of the long division when the denominator is degree 1. So you are doing synthetic, I consider it easier, right? Entonces es x squared, okay, x squared, x and to the 1 power and x to the 0 power. You organize the numerator, get 1, 0, because x to the 1 is missing, and 1. And you divide it by, instead of -1, you put +1. Remember, it's completely opposite sign of this. This is a factor, and this is the number, or the solution, or the root, the 0 is the answer, factor 0. Bring down 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 2. 1 times 1 is 1, sorry, and 1 plus 1 is 2. Entonces, this, when you have no 0 here, it's because the factor x minus 1 don't belong to this. And the answer is, so actually, we can write this division, x squared plus 1 divided by x minus 1. You can write like the quotient part, is that part, is x to the 0, x to the 1, so it's x plus 1, plus 2, get the remainder divided by divisor. Remember, the formula is quotient plus remainder over divisor. In our specific example, the quotient is this. In this case, is just a linear function. The remainder is 2. And the divisor is x minus 1. That means that part represents our slang asymptote. So y equal x plus 1. So when you are doing the graph of this, you need to consider this line. Okay, this line is easy. This line is, you know, y-intercept is 1 here. And its low is 1. Entonces es wrong and rise. 1, 1. Another point, and you are doing the slant asymptote. Okay, guys. So I bring several examples que summarize everything that so far we are covered. We are covered. Oh no, let me try to do one more example of the slant. Let me try one more example of the slant after we cover the example I bring for you. Okay, one more example. Find the slant asymptote in this rational function. Look, let me show you. Suppose the function g of x is equal to x squared minus 5x minus 3 divided by x minus 2. Entonces now, please try to find the slant asymptote. Okay. Number one, we have or we have no slant. So we, according to the definition of the slant, is when the degree of this polynomial is 2, no? And this degree of this polynomial is 1. Oh yes, the degree of p is greater than 1 because 1 plus 1 is 2, no? So yes, we have. At what value? Well, non-division or scientific division. Either way, scientific division is easier. X to the second, x to the 1, x to the 0. This is minus 3, this is minus 5, and this is 2. And you divide by 2. Opposite sign to the binomial. Bring down 2. 2 times 2 is 4. Minus 1. Negative 1 times 2 is negative 2. And negative 5. So in conclusion, this function g of x, que is 2x squared minus 5x minus 3 over x minus 2 is equivalent algebraically to this expression, que is, this is x to the 0, this is the remainder, que no 0, x to the 1, entonces 2x minus 1 minus 5 over x minus 2. These and these are perfectly equivalent, but we can see clear que that part, que es el linear part, is the slant asymptote. Entonces, the slant asymptote equation is y equal to x minus 1. Everyone follow me? Everyone follow me?
Yes.
Excellent. Beautiful.
Yes.
Okay, so let me now to explain the 7th step that we are doing always when you need to analyze rational function. Okay, this is the graphic rational function procedure, maybe, right? Okay, it's line guide, whatever. Graphic rational functions. What is the step 1 to do that? Always. Step 1 is number 1. Okay, factor express in factory forms, a factorization, factory form expression. In other words, you factorization the polynomial at the top, factorization the polynomial in the bottom, cancel out the same factor, so conclusion with no common factor. And the factor gets gone and the factorization as a whole. So you determine the whole here. Okay, and you working so far in the step 2, no using the original expression, no, using the new one gets easier. Okay, step number 2 is find the Y-Intercept. What is the formula of the Y-Intercept, professor? Oh, well, it's easy. It's evaluate the function in 0. This is the formula that you need to remember. Now find the x-intercept, because this is an important point. No? In any graphic you are doing, X-intercept, Y-intercept. Well, where's the formula, professor, for finding the X-intercept? Well, f of x equals 0. So this is equivalent to say x0, and this is equivalent to say y0. Because the notation, function notation of y is equal to f of x, no? But I prefer memorize these and these formulas. Okay? Okay, what about number 4? Well, number 4 is important step, is the vertical asymptote. And so what is the formula? Well, the factor que stay alive in the bottom, que I want to call Q, pero little q, no capital Q. Capital Q is the original, equal to 0. It's a formula for finding the vertical asymptote. And immediately, of course, you try to do, in my opinion, this is a moment, okay, I would like, I don't know why, start the graph. You are doing the vertical asymptote using dotted line. You plot the x-intercept, maybe. So the x-intercept, maybe suppose I have 3 x-intercept, 1, 2, 3, or 1 or 2, depending on the problem, no? And you plot that. Okay, number 5 is determine the horizontal or slant asymptote. What is the reason, professor, you copy these 2 asymptotes in one step? Because they are mutually exclusive. See, we have horizontal, we have no slant. And if we have a slant, we have no horizontal. And remember the condition. The analysis that you should do is analysis of the degree. Degree of the numerator is equal to the degree of the denominator, the degree of P is equal degree of Q. Yes, we have horizontal. At what value? And the division of the 2 leading coefficients is the horizontal asymptote. And that's it. No. If the degree of Q is greater than degree of P, we have also horizontal. But this is special at y0. And slant is when the degree of the P is equal to the degree of Q plus 1. So one more. It's greater than, but one more. You have a slant. Otherwise, no. Okay? So this is an important moment in which you need to do the analysis of the horizontal or slant asymptote. When you have this in your hand, well, suppose that you have horizontal. Well, you are doing the horizontal. Okay, and horizontal slant, we have only one. In vertical, no, you have maybe several, 2, 3, 4, or 1. But in the slant, only one. Or slant, suppose que no horizontal es slant, well, you are doing the slant graphic. And number 6 is you testing the symmetry. This is important, and the student maybe forgot. To test the symmetry, you have 2 possibilities, no, 3 possibilities, even, odd, or neither. This is easy. You are making a reflection. For example, you replace x for negative x in our original function. See, the answer stays the same. Doesn't change. That's because it's even. And CS even, I take advantage of this fact. Because CS even, I need to analyze only the positive part because I know that the negative part is exactly the same. Okay, entonces I take advantage of this symmetry idea. Look, suppose que I testing the symmetry, I verify, wow, it's even. Entonces I plot the positive part because I know that the negative part is exactly the same. Well, another possibility is when you replace x for negative x, it's opposite sign. This is also good. This is odd function because I take advantage. Look, this is odd function. The situation is different, but it's good. You need to analyze only the positive part because I know that the negative part is similar. Suppose que it's something like that, but on opposite side. Suppose one pick 1.2 and the answer is 4. When you pick -2, the answer is -4. So you don't need to repeat the negative part. You only do the positive part because I know that the negative part is completely symmetric, but symmetric will respect the origin. In this case, no. In this case, it's better. A symmetric will respect the y-axis. And neither, when you fail this test, it's neither. It says neither, so definitely we need to do the positive part and the negative part completely separately. Okay? And finally, 7. Okay, in my opinion, this is super important moment. You evaluate additional points. So you plot and evaluate additional points to complete the picture. How many points? Well, the point you consider good to see more clear the graph. However, I have some recommendation. Look, let me show you. Again, we come back to this sketch. Suppose that this is my x-axis. I don't care the y part for the moment. In the point number 4, we determine the asymptote. Suppose 2. Suppose que es en 2 and -2. This is 0 in the middle. In the point number 3, we determine the x-intercept. Okay, the x-intercept maybe is, I don't know, 3, 0, -4. Okay, so now we have different partitions of the x-axis. So in order to select how many points, well, you select in any partition one arbitrary value before and after. For example, in 3, I select 4. Y bueno, this is 2. Bueno, you select 2.5. Okay, to have some idea how it look like my graph in this interval. And between 2 and 0, 1. And between 0 and -2, -1. Easy value, not complicated. And in between -2 and -4, maybe -3. And after -4, you select 5, -5. This is the minimum. In this case, 1, 2, 3, 4, 5, 6. But in this specific example, there are another more easy example. Suppose you have only one asymptote. Suppose we have only one vertical asymptote. Suppose 0. Suppose 1 here, one vertical asymptote. And we have only one intercept. And I don't know, and 4. So basically you select here and 5, and between 1 and 4 is the maybe 3, maybe 2, and between, well, between no, because 0 is the origin. So after no, before 1 is 0. In this case, and this is the minimum amount of additional point. In this case, 3, 1, 2, 3. In this case, 1, 2, 3, 4, 5, 6 points. That depending of the vertical asymptote, that depending the x-intercept can determine somehow the partitions of the x-axis. Okay, let's apply everything together in 3 problems I bring for you today. Okay, may I erase the board? Yes or no?
Yes.
Okay.
Yeah, you can.
Yeah, you can.
Example 1 for today. Example 1 for today. Say, do the graph of that function f of x is equal 4x divided by x squared minus 4. Entonces I highly recommend do step by step exactly as I explained. The first step is factory 4. Step 1, f of x is equal. Well, this is a monomial, it stays the same, but this is binomial, and the factorization is x to plus or minus. This is a factor 4. In this case, I can see clear that there are no factors that you can cancel out. Therefore, this problem have no hold. Everyone follow me?
Yes. Yes.
Super. Step 2 is super easy. It's find the Y-Intercept and the formula for finding the Y-Intercept evaluating 0. You can evaluate in the factor 4 or you can evaluate in the region. Either way. 4 times 0 divided by 0 squared minus 4. 4 times 0 is 0. 0 minus 4 is negative 4. 0 divided by negative 4 is 0. And the Y-Intercept is the point 0, 0. Entonces, when they are coincidence, 0, 0 is because this point 0, 0 is both, is Y-Intercept and X-Intercept. Pero maybe in another example, I don't know if in this example we have more X-Intercept. Therefore, we move on to the step 3. Step 3, que is the Y-Intercept. What is the formula for finding the X-Intercept? Is this X-Intercept, X-Intercept. That was Y-Intercept. Entonces, easy. You copy the original. Either way, 4x divided by x squared minus 4 equal to 0. And when you have a fraction equal to 0, is the responsibility to be 0 is only the top part. And this is equivalent to say 4x equal to 0. Yeah, I don't care that part. That part is completely irrelevant. Okay, guys, when you have fraction a over b equal to 0, this is equivalent to say a is 0. Yeah, I don't care b. B is not important. Do you understand very well this? Sure? Answer me.
Yes.
Yes.
Okay. Therefore, I divide by 4 both sides. X equals 0. Oh, entonces es the same que es expecting. 0, 0 is both. It's X-Intercept and Y-Intercept. And this is an important point, extremely important in our graph. What is the step 4? Oh, it's a baric acid. The step 1 was factory 4. The step 4 is baric acid. And how you find the baric acid? Well, you take the polynomial in the bottom, this one, or this one, either way, and you enforce it to be 0. So Q of x equals 0. It's equivalent to say x squared minus 4 equals 0. You can do in the factor 4, or you can do a no factor 4. Either way, in this case, easy is you solve this quadratic equation. X squared equals 4, apply square root both sides. X is equal plus or minus 2. So we have two baric acid, and 2 and negative 2. Another student can prefer doing in the factor 4, you get the same answer. Look, suppose que another student say, no, I don't like this way, professor. I am doing it that way. Separate, x plus 2 equals 0, x minus 2 equals 0. That's mean x is equal minus 2 and x equal plus 2. So actually, in this moment is the moment que personally I want to start graphic. At least to have a roughly idea how it look like our graph. I put every information that so far I get. I get two vertical asymptotes. This is 0, 1, 2, 1, 2, positive 2, negative 2. We have two vertical asymptotes. Here. Here. Vertical asymptote number 1, vertical asymptote number 2. And we plot also 0,0, que remember was the X-intercept and Y-intercept, because it's obvious that the Y-axis is located here. Y, X. Okay, this is the picture that we have so far. Everyone follow me so far?
Yes. Yes.
Step 5. Step 5 is the analysis of the degree. In order to determine if we have horizontal asymptote or slant asymptote. Okay, entonces I copy the original. The original is 4x divided by x squared minus 4. Okay, entonces el degree analysis of this polynomial, actually it's monomial, is 1. And degree analysis of this binomial is 2, no? Entonces, when the degree of the polynomial in the bottom is greater than the degree of the polynomial in the top, we have horizontal asymptote. It's a special case. Special case at y equals 0. At y equals 0. Always, because it's special. Entonces, I plot that. The asymptote is exactly at, okay, the equation for this line, sorry, is x equal to. The equation for this line is x equal minus 2. And the equation this y equals 0 is coincident with the x-axis. This is horizontal asymptote at y equals 0, coincident with the x-axis. This is a picture of the asymptote. 2 vertical and 1 horizontal. Okay, entonces don't forget, when you have horizontal or slant, you need to find a special point in which our curve cross it or no the horizontal, because it's possible, can happen. So now you take 4x over x squared minus 4, que is the original function is given, and you enforce it to be 0. Why 0? Because it's the value of the horizontal. And we come back again to this equation I did before. It's a coincidence. Okay, the solution for this is 0. At this point, que es 0, the red one is 0,0. Is everything. Is Y-intercept, is X-intercept, and also it's the famous point in which the curve crossed the horizontal asymptote. Okay? Everyone follow me? Don't forget this one by one, in this order, guys. 1, 2, 3, 4, 5. Step 6 is verification symmetry. Symmetry. Important. To verify symmetry, you replace x for negative x. And the original equation in this one. 4 negative x over negative x squared minus 4. The action that we're doing is replace x for negative x. Okay, and the top we have minus 4x. And the bottom we have this square become positive. Minus 4. To see more clear, I put this negative in the front. Because this is the same, it's equivalent, no? And we compare this expression and the original expression. And the answer is opposite sign. In conclusion, when you replace x for negative, I discover specifically in this example, in this, in other no, que es minus f of x. And this is the odd function. Y ahí take advantage this idea. Si es odd function, entonces es symmetric, pero symmetric will respect the origin. So when you find in the next step, you find the point. Suppose que yo evalué arbitrary point. Suppose que yo evalué f en 1. And the answer is, well, let's do it. And the step number 7 is additional point. What point I select? Well, I have no idea. Let me try to understand this. I come back to this roughly sketch I'm doing before. And on the x-axis, the only partition I have is 2, -2, and 0. So maybe you select 3. Maybe you select 1. Maybe you select -1. And maybe you select -3. But si I take advantage of the symmetry, I only evaluate 1 and 3 because I know that the answer in -1 and -3 is the same value with the opposite side because the function is odd function. So let's do it by hand or calculator, either way. You evaluate in 1 or in 3. And the original is 4 times 3 divided by 3 squared minus 4. This is 12. And this is 9 minus 4 que es 5. 12 over 5. Entonces the point is the point 3, 12 over 5. Pero I know que -3, using the idea for the odd function, you don't need to compute again before. No, es -3, -12 over 5. Okay, by the way, 12 over 5 expressed in decimal is 2.4. It's good to express in decimal 2.4 because when you plot that, it's better, no? In decimal. It's -3, -2.4. And 1, similar. F evaluated in 1 is 4 times 1 divided by 1 squared minus 4, no? And 4 divided by -3. Okay, entonces the point is the point 1, -4/3, and decimal is 1, -1.3 repeated. You put in the calculator, or in -1 is the same value, but the same, but opposite sign, and it's 4/3 positive. Okay, it's the point -1, 4/3 positive, or 1.3 repeated. Do you follow me, guy? Do you understand everything I am doing?
Yes.
However, I have good news for you because everything we can do using decimals. I explained decimal before, right? Let me switch into decimals. Let's see what happened. Rational function. Okay, there you go. Okay. Let me see. Yes. Okay. Let me share the screen. Decimals, where? Over there. Okay. Do you see them? Do you see? Do you see? Answer me. No? Yes. Okay.
Yes.
Look at this example 5. I call it sample 5. Look. Boom. Look. This is complete analysis, you know. This is look. We have 2 vertical asymptotes. Look at that. Look. And 2. I flash in this. And -2. We have 1 horizontal at 0. Look, I flash in that. I have additional point Can you see clear que the function is odd function? Let me explain. Suppose this point is 4,1.3 repeated. I select 4 and 3. No 1. Ah, no, 1, yes, 1. Okay, this point is 1, negative 1.3333, and this is negative 1, 1.333 positive, no? You see clearly that the function is odd function? And the famous point is 0,0. Okay, who have opened the microphone? Putting off. Let me see who have it. Okay, the only microphone that is open is my microphone. Okay. Decimus. You see. Okay, question number 1. Do you see the position of the horizontal asymptote? Okay, we have only one. Yes or no? Look. Do you see the position of the vertical? Yes or no?
Yes.
Yes.
Yes. And do you see the point? And do you see how the function is odd function?
Yes.
Okay, suppose 3, 2.4, and this is negative 3, negative 2.4. So as you testing the symmetry, it's super important. The only point you plot is the positive part. 1, 2 no, because it's asymptote. 3 and 4. Okay, and the other is exactly the same value, but the opposite sign because it's odd function. Any question, guys? Super good. Okay, let's move on to the next example. Go to the whiteboard now. Okay. Whiteboard now. Okay. May I erase everything? Yes or no? Yes. Example 2. Well, in the example 2, we have the function that the name is g. This is 2x squared minus 3x minus 5 divided by x squared plus 1. Okay, this is our rational function that's given at the beginning. And you need to do everything. Okay, let's do it. What is the step 1? What is the name of the step 1? Who help me? What is the action? What should I? Exactly. Factory 4. Very well. So I need to do something, only do factorization, the top part and the bottom part separately, of course. 2x squared minus 3x minus 5 is a trinomial, and you multiply this number and this number without sign is 10. And the number can multiply, give me 10 is 5 and 2. Well, there another combination, but 5 and 2 is good because 5 times 2 is 10 and 5 minus 2 is 3. So you rewrite. 2x squared stays the same, minus 5x plus 2x minus 5. Do you see this transformation? So I split 3 using 5 and 2. Now factorization, this guy and this guy is separate, grouping. The great common factor here is x, 2x minus 5. And the great common factor here is nothing, que es 1, 2x minus 5. And now 2x minus 5, factorization one more time, is x plus 1. Wow. So the answer is, look, in the top we have the factorization is 2x minus 5 times x plus 1. In the bottom, ooh, I know the professor explained me intermediate algebra. Explain me the sum of the square is prime expression. But we are a student in pre-calculus, no? You see very well that the factorization here, at least in the real field, is impossible. because the only factorization, so basically, so you try to investigate the zeros of this. You isolate x is equal plus or minus I. That means that the factorization of this is xx ii plus or minus. So we can do the factorization of this in complex field, but in the real field, no. That is the reason that the professor in intermediate algebra say, well, no, the sum of a square is prime expression. And leave it like that. We cannot do anymore. Okay? Do you follow me? Factory 4?
Yes. Yes.
Okay, I want to copy this. Factor 4 is g of x is 2x minus 5 times x plus 1 divided by x squared plus 1. Okay, what is the step 2? Help me. Hey, too loud. Noise. Who making noise?
Find the
Find the Y-intercept.
Matilde, no? Find the Y-intercept, she said. And the formula is G and 0. Evaluate 0. When you evaluate 0, look, it's easy. When you evaluate 0 here, 0 here, and 0 here, stay alive only negative 5 at the top and 1 at the bottom. It's negative 5. So the point is 0, negative 5. This is my Y-intercept. Easy. Evaluate 0. My x-intercept is a little bit more complicated, but not too much. Is step 3 is the x-intercept is g of x equals 0. In other words, is 2x squared minus 3x minus 5 divided by x squared plus 1 equal to 0. Okay, you know, when this situation happens, entonces the factor, no, the polynomial in the top is equal to 0. Yeah, I don't care. I don't care this part. It's not important. No important. But I did the factor 4. I factorization this I did before is 2x minus 5 times x plus 1. Oh, I take advantage. This good. Because I separate into pieces. 2x minus 5 equal to 0. 2x equal 5 divided by 2. X equal 5 over 2. Oh, and decimal 2.5. Okay, this is the x-intercept. The x-intercept is 2.5, 0. 2.5, 0. But we have another, no? X plus 1 equals 0 is negative 1. We have another is negative 1, 0. So actually, so far, I discovered that we have one y-intercept, is the point 0, negative 5, and 2 x-intercept is 2.5 or 5 over 2 either way, in fraction or in decimal, 0, and negative 1, 0. So far it's okay? So far it's okay?
Yes.
Okay, what is the next step? Help me. I don't remember. Step 4 is the most important in my opinion.
Vertical acid.
Absolutely perfect. Vertical acid. What should I do to determine vertical acid? Well. You take the polynomial in the bottom, is x squared plus 1, and you enforce it to be 0. I did before that. I did before this. The answer is imaginary. You see, plus or minus I. Suppose I don't know. Okay, you take x squared equal negative 1, square root both sides, x is equal plus or minus I. And when you see, wow, the solution of this is imaginary, it's because, so when you want to discover something in algebra, and you solve the equation, and the equation is, the solution for the equation is complex or imaginary, it's because do not exist. Okay, the thing I try to find gets the baric acid in this example do not exist because it's complex or imaginary, right? Okay, super. Do you understand this or not? And the real field do not exist. What is the step 5? What is the step 5?
Horizontal or slant.
Oh, exactly. Horizontal or slant. Horizontal or slant. Let me copy again the original. 2x squared minus 3x minus 5 divided by x squared plus 1. And you are doing the analysis of the degree. Degree. What is the degree of the polynomial in the top? What is the degree of the polynomial in the top?
2.
2. What is the degree of the polynomial at the bottom?
2.
And when you have the same degree, we have or we have not? Horizontal. Horizontal, we have or no? You need to remember this. So we have two conditions in which yes, we have. Yes, we have. The answer is yes, we have. We have what? Horizontal acid. At what value? At y equals something. And this is the division of the leading coefficients. Remember, horizontal is the aim behavior. And you consider it only in the top. This is the aim behavior, get 2 x squared, and the aim behavior is x squared. And x squared cancel, the answer is 2. And y equal to is our famous horizontal acid. Okay? Now, immediately, can you find that the horizontal acid exists? You need to investigate. Don't forget this part, because the student frequently forgot. If my curve crosses or no the acid. To investigate that, you take the original function, that is 2x squared minus 3x minus 5 divided by x squared plus 1, and you enforce it to be equal to. Because I want to discover the point in which the curve represented by this expression cross 2. Maybe we have nothing, or maybe we have, I don't know. You cross multiply like that, boom, boom. 2x squared minus 3x minus 5 is equal to time x squared plus 1. Cross multiply. Now distribute the property. Is 2x squared minus 3x minus 5 is equal to 2x squared plus 2, no? Wow, look at that. This is cancelled out. Good, I like that. And stay alive minus 3x minus 5 equal to. Okay, let me try to solve this linear equation. It's too easy. It's minus 3x is equal to plus 5. Okay, 7. Divided by negative 3 both sides. X is equal minus 7 over 3. So at the point, negative 7 over 3, okay, by the way, in decimal, is approximately negative 2.3, no? Is the point in which this curve crosses the horizontal. Okay, by the way, see, crosses is because the y value is 2. So the famous point, important point is negative 7 over 3, que the x component, comma 2, represent the famous point in which the curve crosses the horizontal. Okay, now what is the next step? We did step number 5, no? Step number 6 is symmetry, analysis de symmetry. Entonces es G, replace X for negative X, and let's see what happened in the formula. 2 minus X squared minus 3 times minus X minus 5 divided by minus X squared plus 1. When exponent is even number, it's positive. It's 2x squared plus double negative is positive again. Minus 5 divided by x squared plus 1. And we compare this and this. Get the original. Look. This and this. This and this. It's identical. It's exactly the same. Si it's the same, it's even. Si it's completely opposite sign, it's odd. Otherwise, and neither. What do you think? It's even? It's odd or it's neither? Opinion. Opinion.
Neither.
Neither. Exactly. Okay, and neither. Therefore, unfortunately, the positive part and the negative part, you are doing separately. It's not symmetric, unfortunately. Okay, entonces I define different additional point. Okay, let's go directly to the decimals to see the idea. Do you see decimals?
Yes.
Okay, let's move into number next, case number 7. Oh, look at that. Okay, we discover in analysis, we discover that we have one Y-Intercept, que is at the point 0,-5. This in green color. We discover also that we have two Y-Intercept, que is 2.5, and -1 in green color. We discover also that we have one famous point in which the curve, okay, our curve is obvious, the blue color curve crosses the horizontal axis. This is the horizontal. Look, the horizontal is the line y equal to, and crosses at the point -2.3,2. And you take completely, at the additional point. Suppose we have no vertical. No, remember that the solution of the polynomial in the bottom was imaginary. So that is the reason that we have no vertical asymptote. Then you take, for example, 5 or 4, you take 1, and you take -3. And you evaluate into the function and you get the corresponding value, no? Okay, and you connecting to every point. In total, we have 1, 2, 3, 4, 5, 6, 7 points. And this is approximately the shape of the hour graphic. Any question, guy? So if you follow in this procedure, you have no problem. Any question? No. Excellent. Let me move on to the last problem. Okay, share whiteboard. Whiteboard. Okay, erase everything. Okay, whiteboard. Example 3 for today. Okay. is h of x is equal to x squared plus 9x plus 4 divided by x plus 3. Okay, let's do it. What is the step one? Tell me. To remind me, what is the step one? What is the action you should do?
Factor form.
Exactly. Always. And you take the polynomial in the top. Okay, it's 2x squared plus 9x plus 4. You multiply this guy, it's 8, and the combination is 8 and 1. Because 8 and 1 is 8, 8 plus 1 is 9. And you separate like that, 2x squared plus ax plus 1x plus 4. And factoring by grouping. The great common factor in the first couple is 2x. And we have x plus 4. The great common factor in the second is nothing, it's 1. X plus 4. Now, x plus 4 is a common factor, and we have 2x plus 1. Okay, super. Entonces, so far, the factor form of our problem is in the top, x plus 4 times 2x plus 1. And the bottom is just x plus 3, que is only one prime expression. And this is another way to express it, our original function, que the name is h of x. Any question, guys? Factor 4. What is the step 2? Tell me. What is the step 2? I don't remember.
Y-intercept.
Exactly. Y-intercept. And the formula for defining that Y-intercept is evaluating 0, no? H in 0. It's obvious that when you replace 0 in x, in the top we have 4, and the bottom we have 3. And decimal 1.3 repeated. So the point is the point 0,4/3 or 0,1.3 repeated in decimal. So far, follow me, everyone. Step 2. Step 3, sorry.
Yes.
Step 3. What is the step 3?
X
X-intercept. And the formula is h of x is equal to 0. So basically, the only thing you should do is put the polynomial in the top. Okay, is 2x squared plus 9x plus 4 equal to 0. And you solving this quadratic equation, but much better. You take the factor form, okay, did before, did here. And you replace. This is x plus 4 times 2x plus 1 equal to 0, que es equivalent to say que x plus 4 is 0 or 2x plus 1 is 0. You solve it one by one separately. It's -4 and is 2x equal -1 divided by 2 both sides, -1/2. And we have 2x in the set is -4,0 and -1/2, 0. Any question? Any question so far? No problem. What is the step 4? What is the step 4?
vertical asymptote.
Vertical asymptote. And for finding that, you take the polynomial at the bottom. In this case, just x plus 3. And you enforce it to be 0. So the answer is -3. Wow, good, easy. Therefore, we have only one vertical asymptote. Only one. Okay, if you want to start the roughly sketch. Well, my roughly sketch look like that. This is the x-axis. This is 0 and -3, 1, 2, 3. We have the verticals, only one. Okay, and the x-intercept is -4 here, -4, 0, and -1/2. -1/2, I suppose this is -1, and the middle here, the midpoint is a -1/2, 0. Why no? And the Y-intercept, we have 1.3 on the positive. This is 1, this is 2, and the middle here, not exactly in the middle, you know, close to 1, 1.3, we have the Y-intercept is the point, 0, 1.3 repeat. Okay, so actually, summarize, we have two. All right, let me use a different color. The blue color represent the x-intercept. The red color represent the Y-intercept. Okay, I have some idea. Step 5, okay, in my opinion is the most important in this example, is determine horizontal or slant. What do you think? What do you think happened? The analysis of the degree. Let me copy again. Copy the original. The original is 2x squared plus 9x plus 4 divided by x plus 3. And you are doing one more time the analysis of degree. What is the degree of the polynomial on the top? What is the degree of the polynomial on the bottom? This is the key idea to understand this. Degree 2, degree 1. And when this situation happens, when the degree of the top is bigger than the degree of the bottom, and one time, what kind of asymptote we have? What kind?
Slant.
Slant. We have, the conclusion is we have a slant asymptote. For finding the slant asymptote, well, okay, you will perform long division or synthetic division, either way. Let's do a synthetic division because it's easy, I like that. This is x to the 0 power, this is x to the 1 power, this is x to the 2nd power, this is 2, 9, and 4. And you divide by -3, opposite sign to the factor, because it's the 0. Bring down to -6. This is 3. 3 times 3 is -9. And -9 is -5. Remainder is -5. Okay. Therefore, using this transformation, I conclude that 2x squared plus 9x plus 4 divided by x plus 3 is equivalent to sec. The quotient is x to the 0, x to the 1. This is 2x plus 3. Minus 5 divided by the divisor, que is x plus 3. And I can see clear that this part represents the slant asymptote. So the slant asymptote is the line y equal to x plus 3. Okay? Entonces now, the rest is the same, but I want to skip directly to decimals to see the... Okay, entonces my recommendation is, I forgot to say something important. Go to decimals. 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 Here, over there. Okay, do you see decimals now? Yes or no? Do you see or no?
Yes.
Okay.
Yes.
Okay, so now, when you are doing the graph in decimals, and you can use a decimal. Decimals is our free, beautiful, fantastic graphical grade. So suppose in the test on paper, you are doing that graph. You click here in the share graphic and you export. And this is the graphic, that's it. and you download in the format like a picture, and you send me an email by email. Okay, but don't do the graph by hand because it's ugly and you are doing no well, never. So always in this subject we are doing the graph using the smooth. Anytime using the software, you need to learn using the software. Because you one professional, nobody doing the graph in piece of paper, no? Okay, so now let me summarize. Let me summarize this example. This is our original function. This is the asymptote, the vertical asymptote. Look at that, I flashing in -3. And this is our famous line asymptote, is 2x plus 3 is a line. Look at that, I flashing that. And we have, I remember, we have one Y-Intercept, is 0.1.3 repeated. We have 2x-Intercept in -1/2. Look, make it zoom, get -0.5, and -4, right? Now we have two asymptotes, 1, 2, 3 point. We include additional point. By the way, this function is neither. It's the most popular que happen, que is neither. And you select arbitrary point. I select 1, I select -2, and select -5. And you plot that. Is that? Well, too much, eh? Too much. Okay, what is my plan? My plan is next lecture, this Thursday, I want to present the last topic for the test number 1. It's easy. That part is easy. And we spend the rest, so the next week, two lectures doing the review. The review packet I will send to you as soon as possible. Maybe Thursday, I will say, maybe. Okay, and so I want to do one entire week, go over again to the beginning. Okay, review. Now, February 1st, you know, is the due date of the send to me the answer of the test on paper. Test on paper, I would like I send to you the last day of the next week. Okay, I suppose that you are working in the homework 1, 2, and 3, and Alex, plus the test 1. So everything is due February 1st. So if you have some problem, you let me know. So you communicate. I am your teacher. I am your friend. Any issue, any problem, I communicate with me. So you don't communicate, you ignore me. And then when I check in, you have 0 point for you. Okay? Okay. Do you understand the idea? It's clear or no? No, this is the moment to ask many questions. Come on.
Yeah, I understand.
Excellent.